introducing their Cloud Innovation Hub and how it helps shift the company culture into a motivating environment for creativity, for skill development, and for true inspiration to thrive. So this allows people to learn from one another and to connect businesses and technological value through creative exploration. So the Innovation Hub trend has been growing due to its ability to help companies to hold off disruption. And companies are also experiencing improved performance, and I think they also see competency growth. So a culture of collaboration is really a part of a global trend that's marking the shift towards team-based organizational models, because it's much more effective and it's much more efficient for succeeding in today's really dynamic, really changing business environment what we see. If we look at today, 31% of the surveyed companies reveal that most, maybe even almost all of the work is done in teams. And in the very near future, there won't be any leading company that doesn't function with a primary team-based structure. So companies are strategically improving and team collaboration and increasing digital transformation initiatives with cloud solutions, which not only allows the personnel to communicate more effectively, but it enables them to enhance the customer experiences as well. So here we can see that Oracle shares some examples of how this proactive solution has helped them to create better solutions for their customers.
So I mean, we over the last 5 years or so, there's been a very focused campaign and a very focused effort for Oracle to really go and recruit kind of, Mark and Larry. They're kind of talking about the next generation workforce for us, and that was, the initial experiment was mainly targeting to our sales roles and hiring kind of out of a lot of campuses in the U.S. really and build these hubs as really a concentration of new kinds of thinking to solve specific problems and business problems and help the company sort of build or innovate from within. So about two years ago, my leadership and inspired by Mark, and Mark's then got engaged, really challenged us to say, what can we do to really change the way, the technical teams that touch our customers, change and innovate and modernize to, align to kind of where not the market is today, but kind of where it's going. That's kind of when my job started in building up the cloud solution hubs. And that's, so from the very beginning, our focus has really been, how do we hire people who can build new solutions? But in the past, we have been quite product centric. But this time, really, my challenge to the organization, and you'll see some of these projects, is let's not necessarily obsess just about the tool and the technology, but let's obsess about the problem, and let's be the hungriest problem seekers in our customers. And sometimes our customers don't even fully understand that problem coming up, whether, much like how Oracle is being attacked by a lot of new entrants to the market, our customers are getting disrupted by a lot of new entrants. So we're sometimes, we're showing them some solution that they're immediately reacting to. Yes, this is an immediate need, and we need to kind of go solve that problem. But then a lot of times we're putting kind of art of the possible type of solutions in front of them to say, hey, have you thought about this problem that you may not yet understand, that whether it's blockchain or whether it's virtual reality, whatever the tool or the technology is, it's usually creating some kind of a value proposition which will give somebody a leg up. So we're trying to be proactive, and the customers that we're working with, we're trying to really take that approach. Is let's go build your next business, or your business modernization, transformation, whatever label you want to put on top of it, but being very specific about, let's go solve those problems. not just in a PowerPoint slide, but let's go actually build it with our developers, and that's what the hubs are. It's basically, I've got about 600 or so developers across the globe, but it's in these hubs. We have 4 cities in the US, and one in Bangalore, or one hub in Bangalore, but everybody's essentially a full stack developer in these hubs, and they're just waking up every day thinking about how to leverage product innovations, and you just heard about the OCI innovations. There's those innovations, but we're trying to translate that to problem-solving exercises with our customers.
So how is this different from your typical innovation lab that every big company seems to have?
I'd say there's some similarities. There's definitely some clear differences. From a similarity perspective, we created a culture in these hubs which is very much inspired by, like I said, big problems, challenges that we want to take on. We have a culture of sort of collaboration. People are not being told what to do, but it's as much as possible self-driven. It's very heart-oriented. So we work on things that we actually enjoy. So from that perspective, I think we share some characteristics with some of the innovation centers that are out there. I think that the main clear difference is we are here with a purpose. Our main purpose, and I just talked about, is we don't just do science projects and just tinker for the sake of tinkering. That is not our mission statement. Our mission statement is, build and continues to innovate with technologies that solves more than the problem of my boredom. So it has to solve somebody's, and our customer's problem. And so that's our orientation is very much along that. Which if we're from a typical innovation center, they get a lot more just free space to do whatever they want. We are very purpose driven.
So while I think Naveed can kick us off, you want to introduce?
Yes, I just wanted to say, I think there's some slide switching with whoever is controlling the PowerPoint. Oh, it's right. We want to take this opportunity to actually, we're trying to get away from talking about it too much and just showing you what's going on. So we were going to feature 4 work-in-progress projects, like live view into some projects that I was just talking about. And we're going to demonstrate the workings of each of these solutions. The first one, we wanted to, Naveed will kind of get into it, is it's really focusing on the problem of using data to forecast the future. And this use case you'll see is mainly around, it's a city bike use case. So if you're a Lime or a Bird user, you know what I'm talking about. But essentially, if you just think about it at a little bit higher level, it's essentially solving the problem of asset utilization. And we're trying to predict, tomorrow or next week or next month, using a lot of data now that's available to us, and using our machine learning capabilities in the autonomous database, we want to predict future demand. And then that's just an example problem we took up, and kudos to Naveed and the team. They think to build something pretty interesting. So Naveed,
thanks a lot.
Yours.
Hi everyone, I'm Naveed Yahmazadeh, so you can totally forget about my family name and call me Naveed, as Hamza did. So today I'm going to talk about a project that we built, which basically uses machine learning model, predictive machine learning model for demand prediction. And specifically, we choose the bike sharing system, which we have in different cities. So with the bike sharing system, one of the main challenges that they are facing every day is the unbalanced demand at different locations at different period of time. And the way they are facing, the way they try to resolve this problem right now is they're monitoring the situation in real time, and once they see a station is running out of bike, they're basically sending a truck to some other station with surplus of bikes and bring some of those bikes to this station to balance the bikes at every single station. All right, but this solution is a reaction to the problem after it happens. And if we are considering big cities like San Francisco, which we are here, it easily means spending 1 or 2 hours to be able to resolve the problem. What we built is a predictive model which is able to predict demands at each of these stations ahead of time, which helps these bike-sharing companies to be able to have the optimal redistribution schedule ahead of time. And the way we are building this solution, the way we build this application, is by using Autonomous Data Warehouse and Oracle Analytic Clouds. We use the Oracle Analytic Clouds in order to try out different ideas and hypotheses in a fast pace. And once we figure out which solution is the best answer, we switch to Autonomous Data Warehouse, and we can operationalize that in large scale. And I'm going to show you in real time that how we can use Oracle Analytic Clouds to build this model and how we can operationalize that in large scale and get all the benefits. So before going over how we can build this model, let me start by showing you the data set that we are using for training the model. So in this project, we use historical bike demand data set in more than 500 different stations over some period of time, which was collected in 15-minute intervals. So if you look at this column, you can see the times are in 15 minutes, and we integrated this data with the weather information at each of those locations at each of those times. Something like the temperature or the wind speed or wind direction. Why? Because the hypothesis that we want to try out is how weather impacts demand at each of these locations, and how we can predict the demand by using the weather forecast for future days. All right, so let's go ahead and build this model. The first way I show you is how we can build this model without writing a single line of code by using Oracle Analytic Clouds. This is useful for business developer and business analysts who knows the business, who have these ideas, but they don't know how to build a machine learning model. So at this point, let's assume that I'm a business developer, not this crazy hair, and I want to try out my hypothesis. So in order to do that, I can go ahead and connect the Oracle Analytic Clouds to the Autonomous Data Warehouse where I store my data set. So I have established this connection. I can access the same data set that I showed you. Once the data set is loaded here, we can go ahead and select the columns from this data set that we want to use for training our model. So let's say we want to use the entire data set. So we select all these columns. And the next step is where we need to find which kind of algorithm we want to apply to our specific problem. So as you can see here, there are 4 different classes of machine learning algorithms built into the Oracle Analytic Cloud service available for us to use. We have numerical prediction class of algorithms, binary and multi-value classifiers, and clustering algorithms. And also we have the option to bring our own model if you have some in-house developed model. But again, at this point, the assumption is that I am the business developer, don't know that much about machine learning. I just know I want to use a model to predict the demand, the number of bikes available at each station. So I can go to this class, and as you can see, there are 4 different classes of 4 different machine learning algorithms available for us to use. For example, models like linear regression or random forest or elastic linear regression. These are basic machine learning models, which if you open any machine learning book, you will see all these names. So all of them are available to our business developer. So let's say I just heard linear regression is a good model. Let's go select that one. So as you can see, all the parameters for this model is set by default by the system. The only parameter I need to specify is what I want this model to predict for me. I want to predict the number of available bikes. That's it. I select that. I save this model. Let's say bike share LR. I save it here. And that's it. I can run this data flow, which basically it trains this model on the data set that I showed you at the beginning. So this step takes something like 3 to 5 minutes on the data set that I have. So in order to save some time, I have created this model before. This is the linear regression model. And not only I've created the linear regression model, I have created 4 different models by using each of those available algorithms. Why? Because the very first step in solving any machine learning problem is finding out which algorithm gives me the best solution, which algorithm fits the problem the best. And here, we spent something like 10 to 15 minutes to build the linear regression model. Why not spending an hour trying out 4 different algorithms and making sure we have the best algorithm to use? All right, we figure out linear regression gives us the best result. The result is good, so our hypothesis makes sense. But are we done? We want to be able to get real business value out of it. We are collecting data in minutes or even seconds, and we have huge amount of data. So we want to be able to use all those data. We want to be able to apply these models in large scale. In order to do that, what we can do is building the same linear regression model by using Oracle Machine Learning tool within the autonomous data warehouse. So by using Oracle Machine Learning tool, we can build machine learning solution within the database. What's the benefit? The benefit is that rather than moving data to another service to build and apply machine learning model, we can bring the model here. And that means we don't need to move data. We can get better performance because we are not limited to the amount of data that we can move to other service. And also we can get a higher precision in our model because we can train it our entire data set. So in here, I'm showing you some piece of code which I have developed for this project, which applies this model within the database. I don't want to go over the details of this code. Probably you don't want me to do that either. But what I want to tell you is that when I say we need to build this model within the database, I don't mean we need to build and write the linear regression model from scratch. There are packages and libraries available for us which enables us to apply each of these well-known machine learning models. For example, in here, we have the linear regression, and as a data scientist, which believe me I am, I have my hair as a proof of that, I can spend my time on adjusting all these parameters to tune up my model to get the best result. Also, by being able to create this model within the database, I can automate the entire process and schedule it within the database. So basically, I can create one wrapper function which goes over each step after the other. And once that wrapper function is created, I can set up a job within the database which basically every day at 12 a.m. retrain the model based on the fresh data that I've collected on that day. And this process all happening at once. All right, so we built this, but what's the value of this model? How we can gain value from such a model? So next, I want to show you 2 graphs. One, I want to show you a graph which basically we want to make sure the model is able to predict the value with high accuracy and we can trust its prediction. So in here, each bar shows the actual number of available bikes at each hour at a specific station. And the purple line is the predicted number of available bikes by our model at the same time at the same location. So, as you can see here, the purple line is actually following the trend in the actual number of available bikes. And if you look at each of the predicted values, you can see it's very close to the actual number of available bikes at that time at that location. That means our model is able to predict this demand with the high accuracy. So we can trust its prediction, and we can look at its prediction for a future date based on weather forecast. So in this graph, we are looking at predicted number of available bikes at the same station at each hour for a future date based on weather forecast. What can we learn from this? Simply by looking at this one graph, we can figure out tomorrow around 10 and 11 a.m., we have shortage of bikes at this specific station. All right. By having this knowledge ahead of time, we can pass this to the scheduling team, and they can schedule a truck to be at a close-by station tomorrow before 9 a.m., grab some of those bikes from that station, and offload it here before 10 a.m. Because by being able to predict this behavior, we want to prevent it from happening. So tomorrow when we are monitoring the situation in real time, we don't want to see this behavior. Also, we can provide this information to the user. So we know there is a user who is going to this station every day around 10 a.m. So we can send them a notification ahead of time and let them know tomorrow, for some reason, we're going to have a problem here. And this way, we are not losing their business. So this was just one example of how we can leverage Oracle Cloud Services to build a predictive machine learning solution for demand prediction. And specifically, we use Oracle Analytic Cloud for trying out ideas in a fast pace without writing a single line of code. This enables more people, like business developer, business analysts, who have some business idea to try out their hypothesis without depending on a data scientist. And once we figure out an idea makes sense and give us some result, we use autonomous data warehouse, which enables us to apply machine learning model within the database, which brings more security, better performance, and higher accuracy in our models. So in summary, what I showed you was one project where we built and trained a machine learning model within the database. And basically, by leveraging autonomous data warehouse and Oracle Analytic Cloud, we were able to facilitate the entire process. Rather than spending months to build such a solution from beginning to the end, we spent less than 2 weeks to build this solution by leveraging these cloud services.
Awesome.
Great, thank you. Thank you.
So I think this is just an example of how we are trying to have a whole new set of conversation with a lot of our customers. A lot of customers, they're not even yet thinking about, hey, do I have enough AI ML-based forecasting capabilities? They're still dealing with, oh shoot, there was a giant storm, and therefore, a lot of these bikes moved out. So I want to just call out, and we have a theme to each of the projects we want to show. This was the AI ML kind of a use case. Now let me switch to the next story, which is actually more of an IoT-centric use case, and the problem there is a healthcare problem. I wanted to invite Wilson and Dylan go. Oh, they're dramatic.
Come on, guys.
All right, come on in while they're setting up. So just the use case, really, and we had a version of this, by the way, last year. We did something similar here. We had a similar use case around just better monitoring health statistics, kind of think of like some telemetry on the human body, and then trying to get as live data as possible. So healthcare providers and doctors, they have a very closer view of, and then potentially even preempt issues and crisis points that can happen to anybody. So we want to just take a quick few minutes and talk about Beat to Beat. Is that now our name of the project? Yeah, the project name is Beat to Beat. Tilden and Wilson, take it away.
Yes. Hi everyone, my name is Tilden Chima.
And I'm Wilson Randall.
And we are cloud solution engineers. We built this IoT demo based on conversations with a medical device company that was interested in devices and IoT. And just to kind of give a little bit of context as to why this was important for us and important for the company that we were talking to. So medical device companies and hospital systems today are really collectively tackling some of the most difficult challenges that are affecting the cardiovascular system. But the challenge really is that a lot of patients around, especially patients who suffer from cardiac arrhythmia stemming from unknown causes, still have to have their cardiac activity monitored 24/7 without having to go to a doctor or a pharmacist.
So using Oracle Stream Analytics and Oracle Integration Cloud, we created an end-to-end Internet of Things solution that, based on conversations with this medical device company, that monitors a patient's heart 24/7 for any cardiac irregularities. And if an irregularity does occur, then our solution will automatically reach out to emergency medical services So this could be other interested parties as well, such as a doctor, a pharmacist, or any other emergency contacts on file, in order to ensure that they get the immediate medical attention that they need. So let's go ahead and take a look at how it works.
So for our demo, what we did was we prototyped a cardiac device using our heart rate sensor and pulse oximeter, as well as a GPS module. However, our device honestly could really be any device on the market that is readily worn or capable of wireless communication. So just to kind of get a show of hands and bring this a little bit, down to earth, how many people in the room own a cardiac device monitoring system or a device that monitors their heart rate or pulse oxygenation? Think the Fitbit, the Apple. Nice, so good show of hands. And so essentially, real-time heart rate and pulse oxygenation data can be sent from our devices, as well as your devices, to the Oracle Stream Analytics platform. Now, while on this platform, we're able to see this real-time heart rate data and pulse oxygenation data in accordance with reference patient data from a database. So you can see in this case the patient's demographic, for example, their race. You can see their allergies, e.g. their drug allergies. You could also see their insurance information. So in this case, our patient has United Permanente as their insurance provider. And you could also see the emergency contact information of that patient, coming on to the platform.
So together with this streaming device data and the reference data that we have coming in there, which by the way could be from a hospital or from a third-party database system, we're able to gain insight into various cardiac metrics of the patient, including heart rate variability, as we can see here, as well as any other cardiac events or cardiac measures that you're interested in, such as pulse oxygenation, heart rate, etc. And with this new insight, we're able to determine if a patient has actually had a cardiac event, and if so, we're able to determine the patient's current physical geolocation, and then we can actually get their address from that.
So for our demo, what we're going to show today, we are going to simulate a cardiac event by placing a fingernail covered with dark nail polish on our device. And this acts to do two things primarily. So the dark color of our fingernail causes the pulse oxygenation levels to fall below 95%, simulating hypoxia. And then the dark color of the fingernail also causes the sensors to misread the heartbeat detection. And so this is also reconcilable with cardiac arrhythmia. And so if I were to place my dark fingernail on our device and then simultaneously go to the Oracle Stream Analytics dashboard, I'm going to move that right here. You'll have 3 hands. Can you click on that? Thank you. So I could see these cardiac events happening in real time. I could see the heart rate and SpO2 information. I could also see the heart rate fluctuation on the dashboard. And if I were to scroll down, I'm able to see the cardiac events happening in real time, as well as the patient's current location or geolocation. And if I wanted to drill down into it, I could find specific information about their address, so on and so forth.
Now, if this cardiac event is determined to be of average or lower than average risk, so not a critical cardiac event, then that cardiac event information is then forwarded to a third-party text message service, which then triggers an alert on the doctor's or pharmacist's phone, which we'll see right here in just a second, as Tilden here has simulated a cardiac event. There it is. So if we go ahead and open up that message, we'll see that it lists the name of the patient, their ID to correlate with the reference patient data in the database. As we can see here, it has their current location, so Oracle headquarters. Then if we go back, it'll also have a link to an automatically generated report. So this is going to be a PDF that's dynamically generated based on the patient's information and the nature of that cardiac event. So we can see here the name, Tilden Shima, the patient ID, history of cardiac illness, risk factors, medical history, and also prescription information, just so that the doctor has that on hand if a cardiac event were to occur.
And so, well, while we're not going to show that in this demo, thinking a little bit more about the bigger picture, in the case of a life-threatening event, what could happen would be we could mobilize or assist 911 or emergency responders. So, right now in the medical device space, medical companies are building medical assistant bots that elderly patients at home could have, for example. And so what could happen would be, with the power of our integration, our app integration cloud suite, we could, maybe send a medical assistant bot and program them to use an in-home positioning system, figure out where the patient is, and deliver some life-saving medication. So those are some of the bigger ideas that are out there, and that in the future we're hoping to work with our customers and clients to help further that space. And so just before we wrap up, let's just kind of cover how this was implemented from a cloud technology standpoint. Now, a couple of products or cloud services were used to create this. Now, on our first left end, we could see Oracle Stream Analytics, which was the Stream Analytics platform that our cardiac device wearables are connected to. And this is where the real-time heart rate data, as well as pulse oxygenation data, was also sent to. Now, in addition, connected to our Oracle Stream Analytics platform is the Autonomous Transaction Processing Database, where the reference patient database, so their demographic, their race, their drug allergies, all of that information is held and being pulled in real time to the Stream Analytics platform. Now, on the right end here, where our healthcare professional is at the ultimate end, we have the Oracle Integration Cloud, which is connected to our text messaging application, as well as Oracle Object Storage Cloud Service, where our automatically generated reports could also connect this to a medical assistant bot or to emergency services to help mobilize or assist the patient. Now, finally, in the middle of both of these, we have Oracle API Platform Cloud Service, which acts as the mustard of it all, trying to put it all together. It allows for controlled access between Oracle Stream Analytics and Oracle Integration Cloud.
So there we have it. This project is a prime example of the Oracle Cloud, sort of looking at the world not for what it could be, but for what it is currently. So we understand that by empowering medical device companies and the healthcare system at large, that we're able to raise our view of what humans can do.
And so really what we're doing here is that using Oracle Cloud Services at the back end, we have empowered both the doctor, the pharmacist, the healthcare professional at large to better serve their patients. And it's our hope that it would ultimately save lives. Thank you.
Thank you, Wilson. Thank you, Tilden. So I think I just wanted to make one additional comment here. This project actually came about both because we had customers asking, thinking about these problems, but actually we had a few people we hired. Most of the folks you're going to meet here have probably been here at Oracle less than a year. They were hired last summer, so it's about 9 months or so. But a lot of them came with, the desire, with some kind of a healthcare background or academic, they're in school or some limited professional experience. But a lot of it came from them about the idea to apply these tools to solve this kind of a problem. And we also have customers. It was just one of the things we're starting to see out of our hubs is, there's a growing pattern of it's homegrown and customer demanded, and it's starting to meet in the middle somewhere. So which is an interesting pattern to observe. All right, so we're going to switch to the next one, which is more blockchain oriented. Again, probably the biggest fad in the market right now is the word blockchain, and it's anybody and everybody like, what's my blockchain project? This think of it a little differently. That we are working with one of the largest retailers in the U.S. and they have a massive supply chain problem where they want to track product defects or component defects all the way, trace it all the way from the manufacturer of those components all the way to their shelf. And blockchain is just a tool to solve that problem of traceability end to end. So with that, I'll let Akash and Arvi take it away.
Great. So hey, I'm Arvi, and
hey, I'm Akash.
We're from Western Hub, and we are here today to present you the project of Supply Blockchain, which we developed for a large retail customer. So the problem the customer was actually having was about number of returns exceeding the threshold, and this was impacting their business obviously. So in order to address and resolve this problem, we have leveraged Oracle's blockchain cloud service and analytics cloud service. Before we get into the demo, we will be enacting basically. I will be the supply chain manager while Akash will enact as data analyst. So now let's jump into the demo. So today is first of the month, and my company, the retail company to which I'm working, has their crucial numbers out. So basically, the retail company that we are talking about has had a large flash online sale last month, 15th of April. And now I receive a notification on my mobile that my number of returns has exceeded the threshold. So it is a day-by-day application that I'm opening in here. And this, as a supply chain manager, concerns me because for me, customer satisfaction is of utmost priority. So I really need to find out what might have gone wrong. So I would actually take this notification, forward it to my data analyst, Akash, so he can further investigate and let me know what might have gone wrong.
Okay, so it looks like RV sent over a graph, and it says that our number of returns we were processing has crossed a certain threshold, and this is of concern to her too. So let's try to dig into this particular problem and try to understand what's really going on. So let's take a quick look at the orders and returns dashboard that we maintain. So this particular dashboard right now is showing you data for the last entire year, but already said that the problem has occurred due to the flash sale that we just had. So let's try to drill down into that data. So let's focus on the last 1 month. Okay, so it looks like we processed around 8,000 orders, and wow, out of those 791 of these were returns. So that's a return rate of almost 10%. And we as a company have always operated at a return threshold of as low as 3 or even 2.5%. So this is really alarmingly high. And taking a preliminary look at this orders tracking map, it really looks like the problem is focused around New York State. So I'm going to quickly click here and drill down to see what's going on in New York. Aha. So it looks like our dashboard has generally identified what the problem is. It really seems that the problem is that our shipping partner, NYC Bike Messenger, has been processing an unusually high number of returns. And as someone who travels to New York often, and I'm pretty sure a lot of you do, no one really likes bike messengers, so I'm sure you can relate to that. And a lot of these NYC Bike Messengers, the customer has stated that the shipping box has been damaged. Now, to me at least, that preliminary means that NYC Bike Messenger has been damaging a lot of these packages in transit. But I want to take a closer look at this to make sure that what we're saying is absolutely accurate. So now we're going to switch over to the blockchain transaction inspector and really take a closer look at all these transactions, because this is a single source of truth. It's a trusted network that's used by all of our partners as well as the retail company, and it's something that's available to everyone, so there's no hiding there. Everything here will be absolutely accurate. So let's take a look here. So we're going to go down to shipper and see NYC Bike Messenger. We want to look at the last 30 days, and we want to only look at those products that are damaged. Wow, okay. So it looks like there really is a problem, because there were a lot of these packages that were delivered on the 15th of April when we had our large sale, and a lot of them have been damaged. So this does not look good. But let's take a closer look and track an individual shipment to see what's going on there. So randomly, let's look at sneakers. I like sneakers. We're going to look at that one product SKU. So let's see the journey that these sneakers have taken over the past 1 month. So, any minute now. Okay, so they were supplied to us by the Hiva Corporation. They were manufactured on the 10th of March, got in the 20th, and voila. Okay, so they were ordered on the 15th of April. They were shipped and delivered on the same day, and yeah, it looks like we're 4 or 5 days later, the customer returned them due to damages for the shipping box and product. And what we can actually do here is that this is actually tracking the individual location and the person that was holding it. But you could also have a photographic proof of it, because blockchain can process that. So you can have a photographic proof of how this particular product looked like on the 20th of March 2019 when it got into the port in Seattle, Washington. So you can do that to that level. And now that we've spot checked and validated all of this information, I feel much more comfortable sending it out and sharing it with the outside world. So I'm going to quickly send over this analysis that we've built to RV. Great, you can take further steps.
Cool. So now that I have this information from Akash, it kind of makes me comfortable that I can go to NYC Bike Messenger, have a conversation with them, and figure out what the next step should be. So if you think about it, all this would not have been possible in traditional systems that we have today. Because all the applications that we are talking about, all these systems are right now not connected to anything, so the data is all over the place, and it is even difficult to find out who is accountable for what data. So, of course, all this has been possible because, we were able to get to this solution because we used Oracle's blockchain technology, which is immutable and keeps the data and everyone accountable to whatever they are entering. And this blockchain technology can be integrated with supply chain systems. So let us summarize everything that you have just heard in this demo. Like you see here on the screen, at the very heart of the solution is what we have blockchain cloud offering. This blockchain cloud offering seamlessly integrates with multiple ERP applications that belong to different third parties. So all the data, in fact required data, coming in from these systems is pushed to blockchain and is also sent at the same time to autonomous data warehouse. So we are pulling information into autonomous data warehouse so that we can later in future, and an extension to this current use case is that we can have data from external sources, house them in autonomous data warehouse, use its inbuilt machine learning for companies' preventive measures. And all the data explorations and insights are powered by Oracle Analytics Cloud Service, which comes with the day-by-day app, which I showed in the very beginning of this demo, a very interactive mobile application. So here we are with a complete package. So Hamza.
Awesome. Thank you very much.
Thank you.
All right, I know we are tight on time, so we'll get to the number 4, my last two warriors here. Keep us on time. So the main, this is, we call it the smart traveler solution. Essentially, we're working with some of the larger hotel and sort of travel tourism kind of companies in the U.S. This is to just look at a new traveling experience, all the way from leaving your house to, taking a plane or whatever transportation, getting to your hotel to go and relax and have a meal, perhaps. But we wanted to look at that entire sort of life cycle and see how we can use new technology to really enable a better experience for the traveler. That's kind of the general problem statement. So with that, Nardos and Jonathan, go ahead.
Hello everyone, so I'm Jonathan,
My name is Nardos.
and we're from the Reston Hub. And Smart Traveler is a fully automated, fully personalized way of doing travel. So We built this for a large hospitality company based in Northern Virginia. And they came to us and they asked, can you help increase our customer base and improve the customer satisfaction and experiences? So we built Smart Traveler, and it uses various cloud technologies like IoT cloud, mobile cloud, and chatbots. And so we're going to show you two apps today. The first app is a traveler app, and it will help manage your trip from the flight to the car to the hotel. And the next one is a hotel app, and this will help improve your hotel experiences. So let's check out the app. Come on the screen in a bit. Must have disconnected. There we go. So here's the app. I'm going to go ahead and log in with my face. And let's start planning our trip. So San Francisco Airport is the closest one. I will select SFO, and we can travel to JFK. Looks good. I'll select 7:30 p.m. as a departure time for the purposes of the demo. And now I'm going to pick a hotel, just standard travel booking stuff. Redwood looks good. Got to pick a car, pick one of these, and here's my trip details. So it looks good. Let's travel. Okay. So now, anytime I can just check my travel information. Here it is, same details again. And yeah, SFO. So I will also can check my notifications here, and here it shows that my flight was delayed, and it will notify not only me, but the rental car company and the hotel about this incident. Go back here. So the app will also notify me when I need to leave for the airport, and I can check that time right here. Yep. So this is leveraging the power of the IoT cloud, and it's getting data from my device location, traffic data, TSA line data, and it's using that to compute the total time it would take to get from my device location to the terminal. And normally I would just be like checking Google Maps and assuming the worst of the TSA lines, but with this I can just check within the app. So you know, if anyone has a flight at 7:30 p.m., this is done in real time, so 5:19 p.m. would be a good time to leave.
All right, so now that our traveler has arrived at the destination airport, now let's check out what the hotel experience looks like, right? So, so one of the key challenges, especially when it comes to the hospitality industry, is to create a connected and personalized experience for the guests to, drive business or to build loyalty, right? So to kind of solve this challenge, so there are hotel applications that offer apps to be able to check in online or to have a virtual key card. But with the latest advancements in technology, these are becoming pretty standard features, right? So that's the idea behind this portion of the project. So we wanted to create a holistic hospitality experience for the guest. So as soon as we signed into the application, so we kind of wanted to create a familiar experience where the guest would be able to book, hotels, and you'd be able to see the existing reservations as well. And we're also making a smart suggestion to the guests based on the previous travel experience. So based on their profile, we can kind of look at like where they frequently go, and then we'll basically be able to make smart suggestions to the user based on that. So if the guest has a reservation, an existing reservation, you'll be able to see all the amenities in the hotel and also the features that are available inside the room itself. And we can see that this is actually a smart room that the guest has booked. So when I normally travel and I get to my destination, the last thing I really want to do is go to the hotel and stand in line for check-in, right? So I'm sure you guys can relate to that. So we want to be able to offer the guests the option to check in remotely from the application itself. So if we go through the check-in process, we can opt in for a mobile key and click on submit. So these are like the things that you normally see in hotel apps today. So once we check in, this is really where the connected experience begins. So imagine a world where the hotel room actually knows you and can tailor the entire experience based on your previous stays. So imagine if you have a thermostat in the room, it can set the specific temperature based on your liking. It can set the default channel for your TV to the channel that you prefer. So that's basically based on the previous stays that you've had in that specific hotel. And when you go ahead and unlock the room itself, there are a series of things that happen. Imagine the lights, turning on, and also the TV turning on, greeting you by name, and listing out the different features that are available inside the hotel room. So basically inside the hotel room, you also have smart lights that you'd be able to control individually using the application for each room itself. And this can also be, extended to have customized lighting for that specific guest. So you can have a colored tone for the lights, basically when the guest actually wakes up versus when they go to bed and things like that. So the other thing we wanted to do is we wanted to also enable the guest to control every aspect of the TV watching experience. So we actually built the remote right into the application so that the guest can control the different things with the remote control that's built into the app to watch TV, to change the channel, raise the volume, change inputs, and so on. So one of the key benefits of having all these smart devices and technologies inside the room is the ability to actually integrate them seamlessly into the existing hotel system. So that way you can be smart about how you offer guest services to your guests. So for instance, we can leverage the power of chatbots to handle some of the things that you normally interact with, a front desk or a concierge service. So for instance, if we go to the concierge, we can ask it to find, the nearest attractions if we are going there for vacation. So the digital assistant or the chatbot would be smart enough to actually, ask us the location where we are, and then based on our location, it would, basically find us the nearest attraction. So these are interactions that take place with the front desk people normally. So you would be able to do all that with the digital assistant. So as you can see, we have the different results here. And the other things that we can do is if we want to do room service and see what's available inside that restaurant, we can also do that. So we can basically type in room service and then click send. And then based on our query, it would be able to ask us the location where we are. And then once we provide the location, it would be able to pull up the restaurant that's actually inside the hotel and offer the different menus that are available. So we'll also find the nearest restaurant that are available based on the ratings, and also the specific restaurant that's inside the hotel. So speaking of room service, we also wanted to add a layer of interactivity when it comes to the food ordering experience, right? So you kind of wanted to enable the guest not only to be able to order food right from within the application, but also to see and interact with the food that they're ordering. So we're actually doing that through augmented reality. So if we go to the room service application, so every room will have a menu that's available, and then we'll be able to see a 3D rendering of the specific item that we would like to order. So if we want to go with a big, Thanksgiving turkey feast, we can definitely do that, or a breakfast platter, things like that. So we'll go ahead with the red root burger, and then click on submit. So this basically adds a layer of interactivity when you're, trying to order food as well. So another thing that we wanted to add is basically handle some of the simple tasks such as replenishment right from the application. So if you go to replenish, so these are things that you probably run out of normally. So you'd be able to ask for towels and soap and click submit. So this can either be handled by an existing hotel staff or even robotics, for example, right? So you can implement robotics to handle some of the requests from the different users. All right, so let's take a look at how that actually came about. So to go with the architecture, I'm not sure if you guys can see this, but so application that Jonathan demonstrated earlier. So that's basically a travel application. So we're basically aggregating all the data that's coming from Google location services for traffic, airport security, TSA times, and also the user's device location to dynamically calculate when the user should be leaving their home to make their flight. So we're doing that through all IoT Cloud Service, and just in case the flight gets delayed or if it gets canceled, we're also automatically notifying the third party that are involved, such as the car rental or the hotel. So when it comes to the hotel experience, so we have all these smart devices inside the hotel room, so it could be across hundreds of rooms inside the hotel. So the way we're doing that is by leveraging edge computing. So we have the gateway inside the hotel, which is basically getting all that data, and we're kind of like building a profile around that specific guest that's inside the hotel room, and any interaction that takes place, we're sending it to our IoT Cloud Service. And we're leveraging other cloud services such as Oracle Analytics Cloud Service to kind of see like what devices the users are using, and to kind of get an idea of the profile for that user. So this is how we went about building a holistic experience for traveling and hotel.
Awesome. All right, thank you. Many of you might be staying at this hotels tonight, but I don't think you're yet going to see the smart room. This is in the early stages where we're playing with them. Okay, this demo doesn't do full justice because it requires so much additional hardware like smart mirrors and all kinds of IoT devices. We actually in the Reston have these guys actually built out a full hotel room to actually walk people through that experience. But I think we're at the end of the day. We do have a few minutes for any questions anybody may have. Otherwise, I don't want to be in the way of us and the game.
One question. Unfortunately, we run out of time, so it's the only question.
Okay, just real briefly. Elsewhere in the industry, I'm looking at applications like this as being called systems of engagement, and they're a great advance over earlier kinds of systems of record. And I'm just curious about. It seems like you're not using that kind of terminology, which I think would benefit you in the marketplace. That's all. It's really just a comment. Feel free to tell me what you think.
Yeah, we're still learning what the messaging ought to be on the work that we're doing, to be very honest. We're more focusing right now on the engineering of this. Our Oracle is providing a lot of tools and products, but our focus as engineers has been how to go and put them to work for some specific purpose and solutions.
And the cloud is enabling businesses to access all their data much more quickly, much more efficiently, and to use this for their strategic purposes to improve and support all kinds of decision-making capabilities across all different teams and across all the different departments, which ultimately leads to improving collaboration, and it leads to the ability to create new products, to create new services, to streamline our operations, but also to solve challenges, all different kinds of business challenges that companies are facing. So the cloud also creates a culture of democracy. So this means that your teams can have the tools that really let them explore and to test all kinds of new ideas and all kinds of new creativity. So what's the next step? First, define teams in the context of the objective that you are serving within your organization. And it can be internally and it can be externally. Basically, it can be combined. And ensure that you're building the teams that can demonstrate versatile and collaborative work processes. So ensure that the team leaders are really promoting this environment that allows teams to be open, to be innovative, but also to be consistent. And you can examine this team interaction and the effectiveness using organizational network analysis. And you can do that by collecting network data via different types of surveys. So leverage technology to determine how you can improve performance and operations by creating such a collaborative, agile team environment, but also while a majority of the personnel evaluates really the focus on the individual, I think companies should focus and think about doing more team evaluations and team analysis, what makes teams really make work well together. Oracle is discussing their Cloud Innovation Hub and how it helps shift the company culture into a motivating environment for creativity, for skill development, and for true inspiration to thrive. So this allows people to learn from one another and to connect businesses and technological value through creative exploration. So the Innovation Hub trend has been growing due to its ability to help companies to hold off disruption. And companies are also experiencing improved performance, and I think they also see competency growth. So a culture of collaboration is really a part of a global trend that's marking the shift towards team-based organizational models, because it's much more effective and it's much more efficient for succeeding in today's really dynamic, really changing business environment, what we see. If you look at today, 31% of the surveyed companies reveal that most, maybe even almost all of the work is done in teams. And in the very near future, there won't be any leading company that doesn't function with a primary team-based structure. So companies are strategically improving and team collaboration and increasing digital transformation initiatives with cloud solutions, which not only allows the personnel to communicate more effectively, but it enables them to enhance the customer experiences as well. So here we can see that Oracle shares some examples of how this proactive solution has helped them to create better solutions for their customers.
So I mean, we over the last 5 years or so, there's been a very focused campaign and a very focused effort for Oracle to really go and recruit kind of, Mark and Larry. They're kind of talking about kind of the next generation workforce for us, and that was, the initial experiment was mainly targeting to our sales roles and hiring kind of out of a lot of campuses in the U.S. really and build these hubs as really a concentration of new kinds of thinking to solve specific problems and business problems and help the company sort of build or innovate from within. So about two years ago, my leadership and inspired by Mark, and Mark's then got engaged, really challenged us to say, what can we do to really change the way, the technical teams that touch our customers, change and innovate and modernize to, align to kind of where not the market is today, but kind of where it's going. That's kind of when my job started in building up the cloud solution hubs. And that's, so from the very beginning, our focus has really been, how do we hire people who can